Hello everyone. Today I will be explaining about the experiment total hardness. Let me share the screen. What is the aim? We are going to determine the total hardness of any given water sample or wastewater sample by EDTA method. So what is this EDTA? It is ethylene diamine tetraacetic acid. Coming to the principle, we know water consists of carbonates and bicarbonates of calcium and magnesium. So in an alkaline condition, this EDTA, which we will be using as a titrant, reacts with the calcium and magnesium ions of the water and form a soluble solution. These calcium and magnesium ions develop a wine red color when the indicator is added, and the indicator is EBT, Eriochrome black tea, under such alkaline conditions. So alkaline condition means we have to maintain a pH around 10 and more than 10. So when EDTA is added as a titrant, the calcium and magnesium ions, they get complexed and they result in a sharp change of color from wine red, which will have appeared when we will have added EBT indicator, which changed to blue color after the titration, and that is the end point of the titration. The reaction has ended. So the main principle is that a pH around 10 has to be maintained to determine the total hardness. So we need alkaline conditions. Now, to determine the calcium hardness, we need to increase the pH and it has to be maintained around 12. At such a high pH, the magnesium ions precipitate and only calcium ions remain, where we can determine the hardness due to calcium ions. When EDTA is added to the calcium ions, they get complexed and they result in a sharp change of color when the indicator, that is muroxide, is added. It turns pink, and after reacting with the titrant EDTA, it is converted to purple. So pink to purple is the end point of this reaction. Coming to the theory, we know hardness is caused due to the presence of metallic divalent cations. These cations, they react with the soap, they form the precipitate, and also they react with certain anions present in the water to form scaling. Hardness in water is defined as calcium carbonate equivalent of calcium and magnesium ions present in it. We know hardness is due to two types. We say it is temporary hardness and permanent hardness. Hardness may be temporary when it contains carbonates and bicarbonates of calcium and magnesium. So whenever the water is temporarily hard, it can be easily removed by simple boiling, by adding lime soda process. But when the water is permanently hard, we need some specialized processes or water softening processes to remove permanent hardness. So when the water is temporarily hard, we say it contains carbonates and bicarbonates of calcium and magnesium. Permanent hardness contains chlorides and sulfates of calcium and magnesium. We know temporary hardness can be easily removed by simple boiling, addition of lime, but permanent hardness needs special water softening processes such as zeolite process, reverse osmosis process, etc. Next, Depending on the hardness, we have a classification where we say the water is soft, the water is hard, moderately hard, or very hard. When the hardness lies between 0 to 75 mg per liter, we say the water is soft. When it lies between 75 to 200 mg per liter, we say the water is moderately hard. When it lies between 200 to 600, we say it is hard. And when it is greater than 600 mg per liter, we say water is very hard. So these are the prescribed range of hardness for given water. Coming to the environmental significance of water, we all know when we consume soft water, it is tasteless. We wouldn't like the taste of soft water. So certain hard water will have a pleasant taste and our body will have got accustomed to it. So absolutely soft water are tasteless. Hence, hardness up to 600 mg per liter can be relished and we get accustomed to it, and even the permissible limit lies between 300 to 600 mg per liter. Now, the same water is used for domestic purposes. When we talk the various uses of water, it can also be used for growing of crops in the agricultural purpose or for irrigational activities. There, moderately hard water is preferred. Now, when any hard water is used in any industry, it results in the formation of scales. That is, there on the inner coating of the pipe is formed. Because of this, there is loss of fuel. Absolutely soft water, they are corrosive in nature. They dissolve the metals. Hence, soft water is not preferred. Hard water causes incrustation of pipes. Hard water leads to excessive consumption of, say, soaps. It also prevents the formation of lather. There is wastage of soap. When soft areas are utilized to a larger extent, they may result in cardiovascular diseases. The magnesium hardness, when it is associated with sulfate ions, it may relatively have great effects on human beings. When we cook food with such hard water, it makes it tasteless. Even when meat is cooked with hard water, it precipitates the protein present in the meat and makes that food tasteless. Hard water affects the working of dyeing processes. So these are the various environmental significance of hard water. Coming to the applications in environmental engineering, why this particular parameter has to be determined? What is its application? So we know hardness of water is important in determining the suitability of water for domestic and industrial uses. I said when it is soft, moderately hard, it can be used for agricultural purposes. Then I said a human being likes slightly hard water because it will have certain taste, it will be palatable. So in this way, it helps us to determine the suitability, where it can be used, for which purpose. Next, the relative amount of calcium and magnesium hardness will be determined. The carbonate and non-carbonates present in the water are also determined. This all helps us in finding out what softening process, that is whether the water is temporarily hard or permanently hard. Can this temporary hardness be removed by simple boiling or adding lime, or is it permanent hardness? So should I go for a special treatment or softening process where I can include zeolite process, reverse osmosis process? So in this way, it is determined mainly in the treatment plant. It plays a very, very important role. Determination of hardness also is a basis for control of these softening processes. Coming to the apparatus required to carry out this experiment, we need a pipette, a burette, a conical flask, a pH meter, measuring jar, etc. What are the various reagents used? We use ammonia buffer solution, sodium hydroxide of 2 normality, standard EDTA solution of 0.01 molarity, EBT indicator, eriochrome black tea indicator, and murexide indicator. Coming to the procedure, we are going to have a clean conical flask, clean burette, pipette, measuring jars, which are going to be cleaned, sterilized with distilled water. So the given water sample is going to be measured, where we take 50 ml of the sample. You can take any amount. It can be 50 ml, 100 ml. So for our convenience, we are taking 50 ml of the given water sample. We are placing it in a conical flask. And the most important step is to check its pH. So we are going to determine the pH using a pH meter. So when we use a pH meter, the pH meter needs to be calibrated. Once the instrument is calibrated, then we determine the pH of the given water sample. So one of the most important steps is we have to adjust the pH to 10, because we said EDTA reacts at alkaline conditions. So to increase this pH, we add 1 to 2 ml of ammonia buffer solution. Once the ammonia buffer solution is added, we mix it properly and again check the pH using a pH meter. Once the pH is determined and it is found to be 12, we proceed with the titration procedure. The next step is to add the indicator. So the indicator used here is EBT, eriochrome black tea. When we add 2 to 3 drops of this indicator to the sample, it turns wine red. And EDTA of 0.01 molarity is the titrant, which is filled in the burette, and we titrate this sample against EDTA. The initial burette reading is noted down. So we write a tabular column, write the sample number, trial number, initial burette reading, final burette reading, and volume of titrant added. So once initial burette reading is noted, we start titrating the sample. And once the wine red color changes to blue, the end point is blue, we stop the titration and we note down the final burette reading. So the final burette reading minus the initial burette reading, the difference gives us the volume of titrant added. We note it down as V1. Volume of titrant EDTA added is V1. So in this particular determination of total hardness, it is the sample, 2 ml of ammonia buffer solution, and EBT indicator, which gives a wine red color, and the end point after titration is blue color. The second part of the titration is determination of calcium hardness. We know hardness is due to calcium and magnesium ions. Therefore, total hardness is the sum of calcium hardness and magnesium hardness. So in the first part of the titration, we determine total hardness. Now this total hardness is the sum of calcium hardness and magnesium hardness. So moving on to the Next part of the titration, that is determination of calcium hardness. We take the given water sample, the same water sample. We measure 50 ml of the sample and we place it in a conical flask. Now, we need to adjust the pH to 12. So the pH is determined using pH meter. The pH meter is calibrated using buffer solutions of pH 4, pH 7 or pH 9, 11, that is alkaline, and acidic pH value buffers. So once it is calibrated, we determine the pH of the given water sample. Then we add 2 ml of sodium hydroxide of 2 normality, mix it well and determine its pH. Once the pH is 12, we proceed with the titration further. The next step is to add the indicator. We add a pinch of mureoxide indicator. Once the indicator is added to the sample, the color changes to pink. Now we titrate the sample against the titrant EDTA of 0.01 molarity. So the endpoint is purple. We note down the initial burette reading. We titrate it till pink color changes to purple and stop the titration and note down the final burette reading. Now, the difference between final burette reading and initial burette reading will give us the volume of titrant added as V2. So the endpoint here for calcium hardness is pink to purple. For total hardness, it is wine red to blue. So we can see here the endpoint for titration 1, that is total hardness, is wine red to blue, and calcium hardness titration 2, the endpoint is pink to purple. So once we add EBT indicator, we get this wine red color. Once we add this mureoxide indicator, we get a pink color. And once it is titrated against EDTA, we get a blue color for total hardness and purple color for calcium hardness. So these are the endpoints for calcium hardness and total hardness. So y'all can see the figure. So this is the apparatus which consists of conical flask, the burette stand, the clamps. Okay. So in the burette, we have EDTA of 0.01 molarity. And in the conical flask, the sample is placed. So in the first case for determination of total hardness, it is sample plus ammonia buffer plus areochrome black tea indicator. And for determination of calcium hardness, we have sample, sodium hydroxide of 2 normality, and mureoxide indicator. So here, after adding EBT, we get a wine red color, and the endpoint after titration is blue. Here for calcium hardness, after adding mureoxide indicator, we get a pink color, and after we titrate, the endpoint is purple, pink to purple. Next, what are the calculations? So we will have noted down V1, V2. Now to determine the total hardness, we have the formula V1 by volume of sample into 1000 will give us the total hardness in mg per liter. In case we have taken the volume of sample as 50 ml, we need to write as 50 ml. In case it is 100 ml, we need to write as 100 ml. Then coming to calcium hardness, it is V2, volume of titrate added, divided by volume of sample into 1000 will give us calcium hardness in mg per liter. We know total hardness is the sum of calcium hardness and magnesium hardness. We have determined calcium hardness. We have determined total hardness. Therefore, we can find out magnesium hardness where it is the difference between total hardness and calcium hardness. Therefore, magnesium hardness is equal to total hardness minus calcium hardness, which will give us magnesium hardness in mg per liter. We also determine the amount of calcium ions and magnesium ions using the formula where V2 is the volume of titrant added for calcium hardness into 400 divided by volume of sample, and magnesium ions are determined by multiplying magnesium hardness into 0.243. In this way, we are going to find out the total hardness of water. We are going to write the results, and we will be writing down the permissible limits, which is provided by the Indian standards. So the permissible limit lies between 300 to 600 mg per liter. The results obtained are compared with this permissible limits, and the conclusion is made whether the given water sample lies within the permissible limit and is it suitable for various domestic purposes or not. We also can find out, depending on the total hardness, whether the water is soft, hard, moderately hard, or very hard. In this way, we can tabulate our results and to the conclusion. Thank you. You need to answer certain Viva questions. So the Viva questions are as follows. What is hardness? Define hardness of water. What is the permissible limit of total hardness? What are the effects of hard water? Explain the environmental significance of total hardness. Explain the principle of hardness. What are the various applications of hardness? What is EBT? What is EDTA? What is normality? Okay, thank you.